My name's Andrew Dewar, Steel Modular Construction, CC, SMC Africa. We were the nominated subcontractor for the Protea Glen project for Abacus Space Solutions, who were the main contractor. Our system is light steel framing under code SAISC 517. Basically, it's structural drywalling. It is a system where the engineer and architect's drawings are put into a software package called FrameCAD, which we have a license of. And we make up a Meccano-style framework of every single frame, panel, roof panel, etc. It needs to go into the building. That goes to the roll former, which gets roll forms for coil steel into sections, which get brought to site and get put together. They get installed on the concrete slabs, and then a team comes and does the cladding system. From inside out, it's 50 millimeters of gypsum, which gives you a half-hour fire rating, required regulations. A cavity bat, a 100 mil cavity bat goes into the wall. We've got a layer of Tyvek, which is the breathable membrane. We use a 19 millimeter or 21 millimeter shutter ply as a runner strip around doors and windows. That gives us a thermal break. We then use a fiberboard external cladding on that, and we have a jointing system we use to try and get away from nasty cracks which can develop if you don't get your thermals and connections right. So the important processes for us there are hold points on cladding, because everything you do is layering up to another layer of cladding. So that's the system. Externals are render and or paint. So we used, in this particular case, plaster in some areas, and just weather guard. Very good PVA. That's kind of the external thing. Our joint currently is a two-part polyurethane. So basically what we do is we try and make the joint so strong that it cannot break. The board will break before the joint does. And then we use the thermal expansion point. So we actually force polysulfide joints like a normal brick plaster joint we do. And we've had quite good success with that. Not trying to make paint stick a building back together. The nice thing about light steel framing, once that design process has gone into FrameCAD, we had 28 classrooms, for example, designed once. They come out identically. We can sit with the design in the software prior to it and decide where our plug points are going to be. We can decide where our doorways are going to be. We can detail the size of a doorway. All of that stuff gets done and will come to site accurately. So I don't have to rely on people running around with measuring tapes trying to figure out what stuff's going to be. And as long as we've thought of it, which we generally do, we know where stuff's going to go. We know where a basin's going to go, all that sort of stuff. So it does speed you up radically on site. And we've hybridized our systems a bit, so we can use, I wouldn't say hybridized in that sense, but for this particular job we used a structural insulating panel roof as opposed to a light steel frame roof. And that just sped up because you're basically getting a chromatic ceiling with your roof panel and topping in one go. So it really speeds up your construction on site. So that was a huge saving. Speed is the thing you're selling in the system. The benefits you get externally to that are quality, thermals, acoustics, all compliant with 10400 XA. So you get that as a bonus, but speed is the thing that you're selling. So if you don't deliver speed, you've actually not failed on your project, or you have failed on your project. So that's a key to the project. Well, at this particular time, what we did, we put in a drop-in ceiling into the administrative blocks just to kind of give it a more officey feel, whereas the design from the architect in the classrooms was an elevated roof incline. We had 30 degrees talking to 14 degrees on the other side to just give it a bit of interest. And because of the sub panels and the light steel frame beam along the apex of the building, we could create a very nice internal feel for the building. And you get that for nothing, but compliant with national building regulations and zone 1 in thermals. The size of it, 3,800 square meters. You can argue we went into Christmas, so what was the date of practical completion? We got practical completion. We started in August, finished practical completion in beginning of February, but school functional in the end of December, so 15th of December. It was a huge advantage of the system, was the speed of delivery. And then I think the other big advantage we have delivered is the comfort in those buildings. I mean, they are schools. They're never going to get the funding for the heaters and cooling required, and those buildings are thermally very temperate. So you get that for a huge benefit. Yeah. The building system, the integration of the ability to shop a drawing through the trades. The architect's drawing becomes the drawing you're dealing with. So you don't, and the client can also then see visually, because of the 3D model, what they're getting. So you close down those feedback loops that sometimes get lost. Very often clients don't know what they're buying until they see it, and then they get to decide whether they like it or not. And we've noticed in our system that's one of the huge benefits is people like that 3D ability. They get a feel for size and space of stuff, and that has worked in this project definitely. There were 9 alternative building system projects given out for this round of Gauteng Department of Education buildings, just to test out which of these new technologies they were going to go with. There's been no outcome on that, but we did finish and get practical completion first of all the projects. And listen, this is not objective, but it is a very good looking school. We've had great feedback from the client in terms of the visual effect of it. So the architect's vision did get taken to site and got implemented well. I think actually the timing of the project was an important part of it. We had a massive skills transfer. So one thing about bringing a pre-built structure to site and all you're doing is basically teaching people a repetitive task. On top of that means that you can actually take people and turn them into skilled people in a month. By the end of the project, we've got a team of people that I will happily bring from that Protea Glen, and we can use them on other projects, definitely. We've picked up a good 10 names that we will be able to use again. Yeah, so that's quite a big deal for us. I mean, I've got people in a project that we've taken to all over Mozambique. We've had guys in the Congo that we've trained up in 1 month, and they've turned into great framers. So because you're taking design and taking more of that design into the factory, you can trust that you're not reliant on a very high level skill to implement your project. It takes a lot of the guesswork out of a construction project. Listen, it's a very versatile system. I think it's quite a difficult system to have sold to people because people are very resistant to change. What's been interesting for us about light steel framing has been that the higher end purchaser is more likely to go for it than the lower end. And that has been very interesting. It's breaking through. We're getting way more work in this category, I suppose someone else's building. So it's an office, a holiday house, a school, that sort of thing. But we're getting it. It's coming through now in the residential market. And I think this school has shown definitely that the finishes, even though it's a school and it's in a township, are as good as anything you're going to get. I mean, there was a Shoprite Checkers across the road, and you'd go there, and the tellers would ask you, geez, is that a private school? Are we going to be able to get our kids into there? I mean, and that's something you get for nothing. It's exactly the same price costing of everything else going on in bricks and mortar down the road, but it just has a much better feel physically, actually, when you're standing in the buildings, and visually, just much better. So